Okay, so now I switch to English. And start to share the screen. Okay, welcome to this PhD course on the Python language and programming. I know that you are some heterogeneous public, so some students already know how to programs in Python, some others have experience in other languages, some others have no experience at all. So everybody see what I'm sharing now is a short PhD, is a short PowerPoint presentation.
Yes.
Okay. Yes. So now I will start with some pollings. I want to know from you. First, just switch on your microphone and tell me how many have some experience in programming with Python.
For me, 0 experience.
All right.
For me as well, almost 0 experience. Yeah.
Almost 0 experience in Python.
Good morning, Mauro. I am absolutely more negative than 0 experience in Python, but a little bit of experience in other languages.
Yeah.
With fundamentally different characteristics. So I'm here to learn the basics about Python.
It's okay. Mara Murray says 0. Okay, so 0 experience in Python or 0 experience in other languages is different from having no experience at all in any languages. It's not only a matter of knowing the language, the grammar, the syntax of a particular language, but it's more a matter of knowing how to code, how to think in order to write a program in any language. So I know that some of you have no experience at all in programming. The course will be not so easy for them. It will be hard to follow everything. But anyway, I will assume that you don't know how to code, to communicate with the computer. Now, I see some of the possible motivation that you can have to take this course. I see that you are just a lot of students, so the interest in learning some programming language is high. Probably you have different motivations. The general motivation, the most probable are that it could be fun to learn some new language to program. You realize that you need it just to free you from the slavery to depend from other fellows or the colleagues or the people or from programs that you can download from the internet doing something. That could be very simple program. You have to, for instance, to format your data. You have to elaborate and your data comes in a format and the program that you want to use to elaborate them accept data in another format, or the program's output results in a format that you don't like or that you have further to elaborate by losing some time, just switching columns, transferring data from one file to another. Sounds very, very easy task to do, but that make you lose time every time. And so you want to learn how to code simple procedures to elaborate with data in this way. Generally, when one has to start to make some elaboration, generally you lose a lot of time looking for internet to find some application, all the programs doing what you want, but generally the programs you download never do what you want exactly, something different. And more than that, you don't know how they elaborate the data. They implement some algorithm, you don't know exactly what algorithms are implemented, how they are used, what parameters implements. And so you would like to, from one hand, you would like to code yourself, and on the other hand, you would like to learn to interpret and read data in programs written by others. So that could be general possible motivation for which you would like to take a course in the Python programming. But there could be harder motivations, more subtle motivation, that you don't realize immediately, that if you learn to code and to write programs in some language, no matter what the language is, you are forced to understand the problem in depth. So first thing, to write the programs, to solve the problems, you must know every single step of the problem and of the algorithm that are needed, that are required to solve your problem. So when you learn a language and you want to write a program, this is one step, which is very important step, that you learn everything about it. And also you are forced to understand the algorithm that you use to solve the problem very, very precisely, because you have to communicate with a computer, not with another human. The computer is very rigid, it's a dumb machine, it's very rigid, has no intuition, has no imagination, so you have to understand very well and all the algorithm that you have to use. That's the most difficult part, probably in the programming some computers, is to understand the algorithm that you have to invent, maybe, but that you have to implement in some way. Then you strengthen your logic and the skill in the analysis of problems. So a side product of learning a language, learning not only a language, but learning how to program, strengthen your logic and skills. So this is a side product of this activity. And so you have to learn to think algorithmically. That's not a thing that generally humans are not accustomed to think algorithmically. They rely a lot on intuitions and imagination, but as I told you before, if you have to communicate with the computer, you have to reduce your thinking to what the computer can understand. So what you will get from this course? Well, you will get basic tools. Python is a complex language, model complex language. So in 20 hours of course, you will not learn to everything about Python. That's quite sure. So I will tell you a lot of things, but they are not. It will be not enough to sit down and write programs of any type. But at least you should get the basic tool to learn to write code and manipulate and elaborate data. So that's what you will get. And well, essentially you could understand and write code, which appears now at you to be quite esoteric. So this is some Linux code that you will encounter in this course. Toward the end, you will understand what the hell is written there. This is quite strange, but anyway, you will do. And one point is that if you really want to learn, just not acquire some knowledge about the grammar of the language, if you really want to learn to program, you have to practice a lot. So my lecture will not be enough. After the lecture, you have to work a lot, not just in this day, this week, but in the weeks and the following the next month. You have to start writing program by yourself. And only this way you will learn something. Otherwise, all this material I will present will be lost in a few weeks. So if you want to really use this material, you have to work. And learning to program, as I told you, is not only a matter of studying the grammar, the syntax. Learning by heart some more legible vocabulary is like learning a language, a programming language, is like to learn a foreign language. So you have to practice a lot. If you don't speak in that language, you will not learn anything. So you have to start things algorithmically. It is not easy. So here I made a very simple example. One example that you will find again and again in every occasion when you program. Imagine you have to swap the values stored in a pair of variables. So you have two variables, A1 and A2, that contain some value. For instance, maybe that A1 contains the value number 2, the number 2. The A2 contain 1. So simple, these two structure are simple assignment. You assign the value 2 at the variable A1, and you assign the value 1 to the variable A2. And at the end of the day, you want to get A1 equal to 1 and A2 equal to 2. So just a swap of the value of the two variables. And intuitively, what you will think to do is just putting A1 equal A2 and A2 equal A1. So you just swap the variables. But let's see what happens when you do it on the computer. So here's a little movie, very short movie. So you start by assigning A1 equal 2, A2 equal 1. Then you put A1 equal 2 and A2 equal 1. Then you print the results. You print A1, you get 1. You print A2, and you get 1. So that's right. You don't swap your two variables. You just assign the same value to the two. Why? Because the computer has no imagination and no intuition. So you say A2 equal 1, A1 equal 2. Then you set A2 equal A1. So the value 1 is assigned to the variable A2. And the previous content of A2 is forgot, is gone. So A2 assume the value 1. Sorry, and then A1 equal A2, so A1 is occupied by the value A2, and so when you print, the variable A1 is just 1, and the second variable A2 is 1. So you don't get what you want. What you should do is, okay, start again, assigning the A1, A2, and A2 correct way. Then you define a temporary variable. You store the value A1 in the temporary value. Then you copy A2 in A1. And then you copy the temporary value in A2. Then you can print A1, and you get 1. And hopefully you get print A2, you should get 2. Okay, so that's a way to work. You have to think algorithmically. So in this case, it's a very simple case. You have to invent, you define a temporary variable that stores some temporary value of the variable A1 or A2. That's this very, very simple example of thinking algorithmically. Of course, there are many more complicated procedures that you have to think in order to communicate with the computer. This is a very simple one, but give you an idea. So, why Python? Why Python with other languages, with respect to other languages? Why I choose Python and choose a course in Python? Because, of course, there are many other possibilities. You can program in many other languages. There is Fortran, for instance, a scientific field is used a lot. People from information technologies criticize a lot Fortran because it is old, does not have many of the structure that you can find in Python, for instance. But there is a lot of materials, a lot of programs already written in Fortran that are quite good, quite efficient. So Fortran is a good alternative in scientific programming. Anyway, it has some problem. You have Java, for instance. You have other languages that you can use, but I choose Python because for several reasons. First is open source. Open source means that means many things to be open source, but one is that it is completely free. So you can download your Python environment from the internet, and no cost. You're free to use it. So that's a good point. For instance, MATLAB does a lot of things which are common to Python, but it's not free. There are a subset of MATLAB which is Octave. You can use Octave, which is free, but it's just a subset of MATLAB. If you want to use advanced feature MATLAB, you have to pay. So this is not the case for Python. The fact that it is open source is, as a side effect, there are a lot of people working on the project, on the Python project, in developing Python. So Python proceeds the fast way. There are a lot of features, a lot of functionalities that are ahead every year on the mountain schedule. So the Python release that you have now is not the same as the Python release that you can have next week, for instance. There are, of course, the kernel, many things remain the same, but there are additions to the system, no new functionalities. So this is one reason. This is a very lively environment. It is relatively young, so it was born in the 90s. It has no more than 30 years, and it will probably last for many years to come. Instead, other languages are already old, probably they are on the way to be abandoned. So Python is a good choice. It is widely popular. As I said, there's a large community of developers, and also it's very easy to find help in using Python. So there are tons of materials already published on the internet. For any problem you have by using it, by using the kernel, by using some particular function, you can ask directly on the internet by the Google search. In the field of the Google search, you write more or less exactly the problem you have, and you will find many other people already having the same problem, and many people answer what could be the solution for the problem. So the support for the internet is very, very useful. 90% of the time it is successful, so it's really solving your problems. And so what is Python? Just to begin, why the name? What the name of Python? It has not a particular reason. In many other languages, you have the name of the language is the acronym of something. For instance, Fortran stands for Formula Translations. Lisp, for instance, is the list processing. But in case of Python, there is not. Python is not an acronym. It seems that, even if the reason the name is not certain, but it seems that the author of Python was looking for a name to give to name this the language he invented, and he was looking at some series, some comic series in England, which was the Monty Python Flying Circus. Maybe that Rosangel know about this series. And he was looking at this Monty Python Flying Circus and said, why not use the name Python for my language? So that could be the reason of the name Python, the name of the snake. And many other packages which relies on Python use name for which are names of other snakes or other not very nice animals. For instance, there is Anaconda. Anaconda is a larger environment which wraps the kernel Python and many other functionalities. So we will see that. So that's the name. Then it's an high-level language. what does it mean it is a high level language? So many of the languages you will use in your life are high level language. And high level doesn't mean that they are very good quality, and that low level language are not of good quality. So high level, low level doesn't refer to the quality of the program. High level, low level refer to the being more or less far from the language used by the machine. The machine, the computer, is made up of electronic device. What language they understand, the electronic device is just a sequence of high and low voltage and some as input and output of the electric component, the electronic components. And these high and low voltages are translated in terms of numbers, which are just 0 for low voltage, 1 for high voltage. So the program is a sequence, is a program for the machine, is a sequence of 1 and zeros. That is the binary code. So we think that the sequence of 1 and 0 as numbers, binary numbers, and programs that a language that is close to the sequence of 1 and 0 is called a low-level language, which is very close to the possibilities to understand of the machine. So a low-level program communicates directly with the hardware of the machines. We don't program in that way. There are other languages, which is, for instance, the assembler language, which is no longer made of 1 and zeros, but of other instructions, made of other instructions. They take care of manipulating numbers in a way that the processor can understand more or less directly. So the assembler language, for instance, is a language where you take care of taking a number from the memory of the computer, you transfer it in a register of your CPUs, and the CPUs elaborate this number, just make, for instance, a sum of this number stored in a register with another number stored in another register, put the results in a different register, and this register, the content of the register will be transferred to the memory of the computer, and finally is output. So a program that communicates in this way, so taking care of the register that exists at the level of the CPU, is a low-level language, and for instance, is the assembler language. Then there are other languages, many other languages, which are, do not directly communicate with these low-level languages, and so they are called the high-level language. So you write expression and a structure which are more close to the human being thinking, and there are these high-level languages, the structure written in this language are translated by some other programs to the low level, to the lower layer up to the CPU. So the lower level possible at the level of the language is this operating system. And but between the operating system and the high-level language, there are compilers or interpreters. There is difference. I will tell you something about the difference between a language which is interpreted and a language which is compiled. So high-level language requires some intermediate step to go into a low-level language and finally to the CPUs. And this intermediate step is played by, for instance, an interpreter. An interpreter is a program that reads what you write and communicates, translates it to the low-level language and communicates with the CPUs. A compiler is something different. It's also a program that reads a complete programs that you can write in your high-level language and produce an object code, which is written in the language of the assembler, for instance, links to the other libraries that can be present on your computer and produce an executable programs. That all those programs that hand with the extension that you can write directly in the prompt of the DOS, for instance, they are executed immediately. So there are two possibilities when you choose a language. You can choose an interpreted language, or you can choose a compiled language. For instance, Fortran is a compiled language. So what you have to do is write a program in Fortran, then you have to compile it, and you have to link the object code with the libraries, and finally you have an executable code. The interpreted works differently. So immediately when you write an instruction, the single instruction will be interpreted, and you get the results from the instruction. There are advantages by using interactive interpreted language, which is the interactivity. You interactivity with the computer in real time when you use a high-level language which is interpreted. And otherwise, in the compiled language, it is not that interactive. If you have to modify the program, which is not interpreted, you make a change in your program, you have to modify your file, you have to compile it, and you have to execute. If it is interpreted, you modify the program, you modify your single instruction, and you have immediately the results. So that's the main advantage of using interpreted programs is its interactivity. There is a disadvantage for the interpreted languages, which is the efficiency. And a compiled program will always be much more efficient in terms of time it takes to execute, because you compile it once, and then you can use always your executable code, which does not have to be interpreted every time the code is executed. And so this makes a large difference in terms of efficiency. But if you don't have programs which require a lot of computation time, so they are not very intensive in computing, doesn't require so much time, CPU time, there is no, this issue of efficiency is not very, it's not really the problem. So you can use an interpreted language you don't have. So Python also supports the so-called object-oriented programming, which is not, for instance, supported at all by Fortran. So this is a way to write programs which are very well structured. It contains no bugs, at least if you program in the correct way. It makes you easy to write programs that can be recycled and used for other occasions, in other scripts. It makes it easy to write code that can be used by other people. So object-oriented programming is a very good practice in programming. It's not so simple, but we will see something about this OOP. Fortran, for instance, does not support it, but there are other languages support object-oriented programming, for instance, C++, and many others. Now, all the modern language now support this OOP. But we will see what is it with examples. Support. So, in addition to what we will learn from this course, there are official sites containing information about Python, and we will use many of them. For instance, there is a reference site, which is python.org. I will load this presentation on GitHub. I will show you what is GitHub as a repository for many materials. I will transfer this PowerPoint, so we will have the link which I associate to every item here. So we have python.org, anaconda.org. Anaconda is, we'll use Anaconda later. And we have NumPy, SciPy, Pandas, SymPy. or contains libraries that are used together with Python. So Python is the basic language, but seldom we use Python alone without support of other functionalities, other libraries. For instance, this NumPy stands for numerical Python, contains a lot of results and functions to elaborate data that are of interest for scientists. Scientific Python contains other functionalities which are very useful to elaborate data like fitting function, minimizing functions, and stuff like that. Pandas, we will see something about Pandas. Very useful to deal with very large data sets. Contains a lot of function that allows you to download data, structured data. For instance, Excel files can be read by function written in Pandas, and you can elaborate directly by using the function provided by Pandas. You can make graphs, plots, everything you want. I don't report here also matplotlib. We use a lot matplotlib, which is the libraries, a lot of function for making plots and graphs in connection with Python and NumPy. Then there is also SymPy. I will not have the time to cover also SymPy. SymPy, anyway, is very important. It contains all the libraries which you need to make symbolic computation. You have to solve, for instance, a differential equation, and you have SymPy facilities that allow you to solve differential equation, makes the integration at a symbolic level. So numerical, you can solve definite integrals as well as indefinite integrals. You make derivatives. You can do a lot of operation with SymPy. It's very cool. But I will not have the time to cover it. So we'll concentrate generally on Python and NumPy with some view on Pandas, also something concerning SymPy. These are official sites. It contains a lot of materials about all these libraries. But there are many other possibilities to learn the language. There are conferences. There are serious conferences. For instance, SciP site contains a list of large events like conferences touching a lot of experts related to Python and its libraries. And so under this site, conference SciP.org, you have this, I put here some sites. You will find a series released in 2018, 2016, 2014, but you have many others starting maybe from 2013. But if you click here, you are directed to playlist, and there are a lot of very, very well-made tutorials concerning all the aspects of the language. So you will find it, it will take some time for you to follow all of the material, but they are very used because they are really well done. Then you have other conferences, which are a subset of the conference you can find here in this playlist, which are very well done. So I signal special here, a conference concerning Pandas by David Chen in 2019, and a conference concerning NumPy by this guy here in 2019 also. They are very clear but very useful. So it takes it's useful to take your time to follow them. Then if you want to have more information, you can concerning the logical programming and how to write code which hopefully doesn't contain bugs, which could be clean code, so you can recycle easily in your life as programmers. There are conferences by this guy here, which is Bob Martin, is known as Uncle Bob, is very, very nice guy. So they are very entertaining conference that you can easily follow here. There are many conferences by this guy here at It's interesting to find this conference. Then books. There are many books on Python. You can buy and start a little bit. I advise this one. You can find on Amazon also. This numerical Python, this conserved mainly with not only with NumPy but also SciPy and Matplotlib, but also with Pandas. So I bought this some years ago. It's very, very easy to be followed just because it contains this recipe. So you can directly use the recipes that are indicated in this book, and you can implement in your program very, very easily. So as the first step, I advise you to buy a book, at least a book like this one. Then, if you become curious about the language, the kernel of Python, not the libraries, but the kernel of Python, and what's the logic, if you really want to go deep in the language, not the first step, if you want to learn Python from scratch at the beginning, it is not the case to go on a book like this one, very thick book. But if you, after some time, you may want to know something more, what is under the hood of the language. So I strongly advise this book. It contains everything you would like to know about what is behind the language. You can understand and know many new things that you don't find at all in books like this ones. So what are the arguments I will cover in the book, in this course? There are many arguments, you see. I hope I can go through all the material I prepared. By the way, I am a programmer since, I would say, at least 40 years, because I started to program when I was at the high school, so in Haiti. And I started with basics, then I moved to Fortran, then to Lisp, then to C, C++, a little bit of MATLAB, and I moved to Python. So I'm experienced in making in this field, in this world of programming, but I have no experience in teaching Python. So I never taught a course like this one. So essentially, I don't know how much time it would take to me to go all through the materials I prepared. So hopefully I will arrive to deal with, in this course, to deal with least square, general fits, and other specialized aspects that may be of interest for in data science. But I don't know. Anyway, the material is there, and I will try to go through all the materials. So I prepare some material concerning variables, type of variables, conditionals and cycles, function files, and variable scoping, which is a very, very important point that you have to learn in order to be able to write a program in Python or to understand code written by other people. Then there is the point of classes. It is mainly refers to the aspect of the object-oriented programming. So this is a very, very important subject, going with understanding the classes. And then there are all the specialized aspects that that relies on all the previous lecture and aspects concerning the elaboration of data by using some methods which are covered by SciPy, for instance, or from NumPy, all the specialized libraries. So let's start now with the
Mauro,
yeah,
may I ask a question?
of course.
So you were talking about the differences between interpreters and compilers.
Yeah.
And when you have a program language like Fortran, which is compile, you have the option of the compiler optimizing the code. That means in other people, that means making the machine level code that actually runs much more efficient than what you actually wrote.
Yeah.
My question is, does Python also do optimizing when it is interpreted, or is this something you have to do manually?
No, yeah, of course, Python has a lot of, there is a lot of work behind Python to implement optimizer. Maybe I will show you one, which is related to NumPy. There is another library, which I will not have the time to cover it. It is called Numba. And Numba allows you to optimize your codes. Also, there is a possibility to go in parallel computation. So it is not difficult in Python to write programs that work in parallel. So this is very efficient. Another point is that, for instance, the NumPy library contains a lot of functions which are already compiled internally. And so when you use a function which is from NumPy, probably you don't use an interpreted function, but you use a function which has been already compiled and optimized. So they are very, very fast. And if I will have time, I will show you some difference in time. For instance, by using, for instance, on a sorting algorithm, you have a data structure containing numbers, and you have to sort the data. You have to create a list where all your numbers are ordered from the lowest to the higher. And if you use, for instance, a function that you write by yourself on a large set of numbers, can say, for instance, 1 second. And if you use the sort function by NumPy, it takes you 2 microseconds. So very, very deeply optimized. So that generally you think that all the parts of the language are interpreted, but it is not true. Some parts, some functions are already compiled and optimized. If not, you can use this Numba library to optimize your code. There is a full word concerning the optimization, and even on the conference I told you about SciPy, there are lectures and tutorials which concern mainly the optimization issues. And also the parallel is quite useful feature that you can see. So, I invite you now, if you have a computer, or of course you have a computer in front of you, you can download the environment. So if you want, of course, you're not, you have not to do that. But I advise you to download the environment. It will take you some time. It will take us for some time to do that. But anyway, it's important to do that. And you go with a browser on the site of Anaconda. Anaconda is a larger environment than Python itself. It comprises a lot of other libraries. So if you install Python from the beginning, you start to import the library of the current Python. Then you have to install NumPy, all the other libraries that you may need. But if you work with Anaconda, all the relevant materials is already downloaded. So I invite you to go with your browser to the anaconda.org. So I wait some seconds. When you are on Anaconda, you see the name of another snake. You go to the download Anaconda item that you have on the bar and click on the download Anaconda. And you have several possibilities. And what I advise you is to download here Anaconda Individual Edition. And if you have a more or less modern computer, you have a 64 machine, so you have a 64-bit machine, you can directly download this package. Or otherwise, you can click here. You have Apple, you have Linux, you have other version of your Windows system. For instance, if you click here, you can download. If you have a 32-bit machine, you can download here. But if you have a 64-bit machine, you can download the default. Then I don't download it because, of course, I already did it. From time to time, you could. Well, I see. I will tell you later what I want now.
Well, I already have Anaconda because I downloaded it months ago. But do I need some specific version or?
No, for now, no. You could upgrade it. Now I will show you how to upgrade Anaconda. So sometimes you may run things and your environment get corrupted somewhere. So in that case, and I will tell you why. In some cases, it could be useful to wipe away all the Anaconda environment from your computer by disinstalling it using the standard procedure of Windows, and then download it again. Otherwise, if you don't make mess with your files, you can simply upgrade it.
And if I have already some environment which are running with an older version of Python, because I created an environment like this to run a specific program, it doesn't change if I upgrade the system, right?
Generally not. Okay. There should be back compatibility with other environment. So generally, it's not necessary to install it again or to change your program. That could be different. The point is the Reba, for instance. When you install a new version, for instance, now it will, if you download this version, it will install you Python 3.9, Python 3, the version 3.9 something else. But it is in circulation already 3.10. And you may be 3.10, for instance, has new features that 3.9 has not. And in this case, you could be curious, or you want to use this new feature of Python's 3.10 and write code by using this particular feature. So that's a problem. That could be a problem because if you run the program in an older version, older environment, they are not recognized. So be careful when you install a new version, and don't immediately start to write programs by using the new features, because otherwise other people use older version of Python that you may be interested to use your program cannot do that because the new features are not present in the older version of Python. But backward compatibility is generally assured. So when you download, you have an executable file. You can unzip or you will just start your, for instance, I will show you. You should have, for instance, program. I will not, okay. You have a window like this one. You can click on the next, and you go on by accepting the default he proposes you for the installation. Go on, at the end of the day, you will have the package installed.
Mauro?
Yeah?
Should we do this now? Is there a risk our computers reboot and
No,
we get
no.
from it? Okay.
Yeah. Now, since I will give you some time to do that because it's not immediate, it will take some minutes to perform the operation. In the meantime, if you want to ask something else, you're free.
I'm sorry, I have just a question about the installations. So when we go on, at one point it is asked, what about advanced options? And there are two options. The first one is add Anaconda free to my path environment variable, or register Anaconda free as my default Python free.
Choose the default, which is the advised option. Therefore, the other one could be for expert user, but anyway, choose the default.
Okay, thanks.
Okay, now I will show you what you will get. You will get, at the end, in the start menu, you will get this folder, Anaconda free, 64-bit in my case. If you expand it, you will see that you will get this Anaconda navigator. I will show you what is it. Then you have two shell that you can open. I will open this one. You have the Jupyter notebook and a Spider. Spider is the environment which is chosen by Anaconda. The environment, the development environment of the program. So the environment that you can write programs and you can execute them. The Anaconda navigator, and I click on it. Okay, make some work. Take some time to initialize. I never used the Anaconda navigator anyway. I will show you what is it. So this is a window like that, containing all the package, the system that are already installed on your computer, together with a bunch of other programs that are not installed. If you want to install them, just click on the install. For instance, if you want to use RStudio, which is a system that necessary for useful for making statistical analysis data, so you can use it or install. But otherwise, we have this Anaconda prompt or Python prompt here. It could be useful. You have the Jupyter Lab or Jupyter notebooks. Then we will see what they are, especially notebook. You have a console where you can run interactively Python interpreter, and you have this Spider, which is the environment which is generally used to write programs. You will use all of these tools. But you can start these tools not by using the Anaconda navigator, but directly from the menu, from the start menu. So, for instance, you have two shells, Anaconda prompt here. If I click here, this is essentially a terminal on the Windows system. You can type in just DOS program, for instance, a list of the file that you have, file and folders that you have on your, in this case, user content folder, the dir command of DOS. And you can run here, from here, the Anaconda interpreter, just the Anaconda, the Python interpreter, just write in ePython. And you have a prompt like this one. Another shell that you can run is this PowerShell prompt. I here choose character which is large enough to be easily seen in this section. This is essentially the same thing, this shell I created here by using the other prompt, by using this other command here. But it's a PowerShell. So it's a shell which is much more enriched with respect to the shell that you generally use with DOS. For instance, you have a command like ls, which is the analogous of dir, but is the shell that is used, for instance, under the Unix system. So you have a lot of commands that are from the Unix system, Linux and other things. But generally, you are not interested in that. You are interested in Python. So even from the shell, you can run the Python interpreter. IPython. And you have this interactive. This I here stands for interactive Python. And you have a prompt here. When you can type commands, it's just 1 + 1 is 2. So just you can use it as a pocket calculator. And if you want to quit from the shell, from the prompt, the Python prompt, just run quit with parentheses, and you will return to the shell. I can close this shell here. Use this on. Then you have this spider development application. I run it. When you start Spider the first time, probably it will ask you if you want to. No, there is to install another package which is called Kite. And I strongly advise you to not install Kite because it's too invasive. It takes a lot of resources of your computer to suggest in structure, Python structure, checking your code that you already wrote. It could be very useful, but it consumes a lot of resource automation, so it becomes very slow. All the system becomes very slow if you have a large program that you are writing. So I don't advise you to use this. Don't install it. So when you stop Spider, you have several windows of this type. Probably could be a little bit different if you start Spider for the first time. Maybe that you have a lot of panes that you can disable because you don't use. You say disable. There are many of these things are by default they are switched on. For instance, I can open a numbers. Unlock this page. History, something like that. My advice is to close many of these panes. At least if you are a beginner, you don't use them, just consume space on your computer. Files, and also history. You have to do it one by one. Maybe that one that okay, one that you could have installed, for instance, this plot. Now we will see what is it. I will show you it. Okay. So you have two main windows which are important in this case. This is the window that you have on the left. It is the window that you use. It is the editor of the code. It's the window that you use to write your codes. And the terminal on the left, on the right. So on the left, the editor. On the right, there is the terminal. Now I delete this default. Okay. When you start, you can write on the file, and you can write a new file here. You can click on new file, and a new file will open. be opened. And then you can save the file with the name that you want, with save all, for instance. And here you can write instruction. For instance, very simple structure now. You don't have to understand what I write. It is very simple. Every programmers, let's try a new language, start with this hello world statements, their word structure. And then you click on this triangle, green triangle here, and you see the execution down on the right. The file has no name, it is untitled. Every time that you click on this green button here, the file will be saved and executed. And it gives some information on the directory that you are, the name of the files, and the directory in this case, it is user intent. The Python version is 7.29. This is the interactive Python here, and the version of Python that is running is 3.99.7. The release is September 16 of last year. Someone succeeded in installing the package?
I guess, Mauro, I have the fastest computer here, thanks to Matteo. So yes, I've installed and started Spider.
Okay.
One question,
Yeah.
while we wait for everybody to catch up. Where do I go to invert the colors on this display?
Oh,
Because
yeah, there are a lot of possibilities.
there's a lot of buttons.
Yeah, there's. I did it sometimes. There's preferences, okay, on the tools, and then there we have the appearance.
Okay, fine. I
Okay.
was going under view.
Okay.
View would be where I would put it, but anyway.
Yeah.
Thank you.
Okay, someone telling me that this is finished installation. Okay, Spider is a possibility to run the programs, to write and run the programs. Very, very useful when you start to write some serious project. You will surely use it. You get some experience in using it, and it's very easy to use. But for smaller projects, you can also use any other editor, and you can write your programs in an editor which is an ASCII editor, for instance, not of course Word or something like that, but even Notepad or Windows can be used, and your program should be saved with the extension .py. So, for instance, I moved in my shell here in the PowerShell, the Anaconda prompt. I moved by the cd command in a folder, which is this Dottorato 2022. And if I make here, I can see what the files are present in it. And you see that you have a hello.py. This is a script, a very simple script contained print hello world. And you can run your script immediately just by writing Python and the name of the program, the name of the script with the extension hello.py. And you have the execution. So this program is very, very simple. This one, you can open it with, for instance, not with Spider, but I could open with Spider, but for instance, I open it with the block node block, and you see that this instruction which is contained in this file. So that's a very simple program, a simple script, and you can start it by writing Python hello.py. There's another way to run it. It's just writing Python -m hello without extension, and execute it the same way, but there will be difference. Now, here is the program is loaded and run immediately. Here, the program is imported in Python as a module. Now, I will say you, not today, but in later lectures, I will talk to you about modules. Most generally now, just I say, the only thing I say is that module is the name of a program. So in the language, the jargon related to Python, people call programs modules. So when instead of talking about programs, I will talk about generally, I will talk about modules. So hello.py is a module and can be loaded as such as a module and executed by the command Python -m stands for module. Otherwise, you can go into Python interpreter. So in Python, and you can import, but for instance, you can run Python by using this command. I explain why. So I use this command run, which is preceded by the ampersand character, percentage character. This is a major command. So major command which should be are not command of Python, are commands that exist, are defined in the environment surrounding Python, and that can be executed in the interpreter by using these percentage symbols. So they are called major commands. There are two types of major commands. I'll not tell the difference now to you. When I talk about major command, I talk about this percentage and the name of the command, which is really executed. It's not exactly a command of Python, but for some other function that exists in the environment which hosts Python. So run is load your file and execute it immediately. You can also run load hello.py, and you see what happened. The program, the module has been loaded. So it is not executed, but it has been loaded. So that the content of the file is read, and the result is shown here. And then you got the execution by typing the enter from your keyboard, and your instruction has been executed. So load will load the program, but it's not executed automatically. Run, it is loaded, the program is loaded and execute. Then you can import your program. You can import your program just by saying import hello without the extension, and it is imported and executed. So this import hello is the same as writing, as I did before. Disappear. It is a Python -m hello. It is the same thing as import hello, but type it in the interpreter. There are differences, but we will see later. So that's one way to run programs. Okay, now I'll leave this. Then, the Jupyter notebooks. Jupyter notebooks, very important point. So I can run another here. I move in my folder. So CD, desktop, and CD. also see these codes, notebooks, mask. You have all this file in this folder, which have an extension which is EPYNB. So these are interactive Python notebook. This notebook are not contain Python codes, but contain more than that, contain other things that we will show you, and are read by, all this file can be read by the Jupyter notebook. And you have also installed it contextually when you install the Anaconda package. So you simply write Jupyter. Jupyter will launch a server, and this server launches a client, which is the notebook. So I can write here Jupyter notebook. You can try yourself, but okay, and you have created in this way a tab on your browser. So the Jupyter notebook is an environment which is executed inside a browser, the preferred browser that you have. I use Chrome. If you use Edge, it will create a tab in Edge. Firefox, it will create a tab in Firefox, and so on. So you can execute all your notebook. You can see and execute all your notebook in a browser. That's be very interesting feature, common feature, and useful. It is particularly suited for presentations, for didactic purpose. So I will use all this notebook for these lectures. It's very useful for presentation at meeting. I will show why. Now we will use this this notebook once by once. Some will take quite some time. Some others are not very long. But I will show how to start a new notebook. You have here several items. For instance, you have new. You click on new, and then you have several possibilities. You can open text file, folders, terminal. But generally, you can click on Python 3. So if you click Python 3, what happens is here. So this is starting Jupyter notebook. You can save it immediately by clicking on the item here, Untitled, and for instance, I can test here. I write test here, so I call my Jupyter notebook as test. You will find it in your folder, in the list of the notebook that you have available. It appears this test EPYNB. And you start with a cell. This is a cell, typical cell. And this cell can be of different types. The default type is the code, so you can start writing Python code here inside and execute it. Or you have, for instance, Markdown or other possibilities. The most used are code, of course, and Markdown. Markdown, for instance, if I change with Markdown, you can write expressions which are not executed as Python code, but are very useful to write in text by using some syntax. For instance, if I want to write here a title, I put the hash character, for instance, 1, hash character, then title 1. Then I run it, just clicking, not just enter. If you write enter, if you push enter here, you just go to another line in the same cell. If you want to execute the cell, you can clicking here on the run button, or clicking in the same time shift and shift and enter. If you do it, you have this title formatted, writing formatted as it was. If you come back on the original cell and you click twice, it can edit in it. For instance, you can write title 2. Or title 3, you have 4 levels of title. So one smaller than the other, and you have these possibilities. Or you can simply write some text. So that was a title. Let's do that. It was a title, and it will appear this way. You can write formulas with LaTeX, for instance. You have the LaTeX environment. You start, for instance, by writing the integral from, let's say, 0 to f dy. That's provided you know that, of course. We have x close. Yes, execute. Why does not execute? Doesn't work. So I don't know why. I reinstalled the Jupyter notebook, so there may be something has been changed in the setting. Anyway, that's not very interesting for this code because we are not talking about LaTeX. Anyway, this can be useful to write anything you want to present the code that you will write in cell, which are really the code. For instance, look at the following example. Look at the following example, and you can write example right here in the next cell, and it's very simple, 1 plus 1, and so you write your Python instruction, in this case just a sum, and you get the output. And you can go on. So if you have to do a presentation showing your results and how you get results with what elaboration, you can write directly your Python code into cells and execute in real time. So if you change something, the elaboration, you change some parameters, you don't have static image that you present at your meeting. You present a lively session, so you can change the coding the way you want, you can change the parameter, and you can show the effect that this changes and the results you obtain. So Python, Jupyter Notebook are very, very useful. Okay. So you will learn how to use them during this presentation. Now, I will start with the first notebook of the lecture. So officially now I start the course on Python. This, what we have seen until now, just an introduction, what is the environment, what will be the tools that will be used. And we have all these notebooks. By the way, you can find all of the materials on the GitHub. GitHub is a repository, contains that everyone can create its own repository. I create this for the Python course. So if you go on github.com and Mauro Principe, with the dashed site, you will find my place and click on the Python course 2022, and you will have all the notebooks I will use together with some other materials, and you can download it directly by using this code here, button, green button, and download zip. Then you unzip it with your preferred zipper on your computer, and you will have all these files on your computer. Maybe that, so you can do it now. Maybe that during the week I will update some of these files, and I can add something else. So at the end of the course, if you want to have the materials future reference, you better download it again. So to have an upgraded version of the notebook that we use. So first lecture, variables and types. I will open the notebook. It will take some time to open because there's a lot of materials, quite a large number, more than 100 cells. And this lecture, I will tell you, is not very exciting. It could be rather boring for some of you, but the most advanced facilities and the features of Python will be covered in the next lectures. And this lecture will take us the rest of this morning, probably all of the afternoon, maybe. I don't know, because as I told you, I don't know exactly how much time it will take for me to go through the material. But anyway, even if it is not exciting, it is very, very important. If you don't understand this, if you don't learn what I tell you this morning here, you will have problems in the future in programming in a correct way. So it is especially important for people who has no experience at all in any programming language. It could be something that you have already seen in other languages, if you have experience with, for instance, C or even with Fortran. In Python, the type of the number or the type of the object that you're dealing with is very important. So in Fortran, you have, for instance, 3 different objects that you essentially use, which are integer numbers, floating numbers, and strings. In Python, you have many, many more objects. Another warning I said at the beginning is that I told you about object-oriented programming. That is an advanced feature of program like language like Python or C++. And one could say, all right, I am not interested in object-oriented programming, so even if I will use Python, I will not deal with class or object, which are the central point of the object-oriented programming. Well, that's not true, because if you work with Python at any time, you will work with classes, even if you don't realize it. We will work with objects, which are essentially classes. And so the first cell here, I write very simple. Now I do something, I do an operation. I restart and clear all the output I have. So every cell will delete its output. Now, I wrote here two very simple assignment instruction. You have A equal to 1 and B equal to 1 dot. So this A equal to 1, this is obvious for everybody who knows some programming language. It is not obvious to other people. A equal to 1 is not an equation. I'm not putting an equation for which A is equal to 1. It's not testing if A is equal to 1. It's not an equation. This is an assignment function for which I assign the number 1 to a variable which is called A. A is a variable, 1 is a value that will be assigned to the variable, and 1, the number 1, is not an obvious object. Number 1 is an integer object, and as a native object of Python is treated as an integer number. If I write B equal 1 dot, the 1 dot is a different object from 1. So the value is the same. This is always the number 1, but 1 without a dot is an integer number. 1 with a dot is a floating number. So a number which has it is expected to have some decimal part. Now this decimal part in this case is just plain 0, but it does no matter. This is a different object. So I make an assignment A equal to 1, and then the time that I make this assignment, the type of A will be set equal to the type of 1. So at the end of the day, when I run this cell, by clicking on this run button here, I have an instruction that says A equal 1, then print of A, and I write type of A, and I type the type of A. So I see that type of A is the class int. The type of A, look at the language, the nomenclature they use is specific, very precise. The type of the variable A is not any type possible, but it is a precise type. It's the integer type, which is called int, and it is a class. It is the class int. A is an object of the class int. So now I understand it is a little bit difficult to understand now because you don't have all the tools you need. But anyway, there is a class in Python which is called int, and A is an instance of the class. So class is a general object that can be instantiated. You can create the example instance of the class, and in this way I automatically create an instance of the class int. And the class int has a number of attributes, has a number of methods that we will see lately. I know details now, but be aware that this A equal to 1 is not an obvious operation. It creates a lot of other things in your environment. So create an instance of the int class. If I write b equal to 1 dot, and I write type of b, so here you have a printing structure as well as you have here. Look at this printing structure. You have a function, and as a function is so you have a keyword, the keyword print, and a couple of parentheses, an open parenthesis here, and the one which hand the parenthesis here, and the print. The command print will print out in your standard output everything which is written inside the parentheses. And what is written here? It is written this instruction. We have a string. A string is something that it is surrounded by these apices. It can be double or simple, no matter. It doesn't make difference in Python. And so then you have a comma and type A. Type is another function that receives an argument, which is A, and print out the type of the variable. So A equal to 1, then it is executed print, this print, the first print, and the execution is this row here. Print type of A, is this string here, colon, and then the type of A. So the type of A is class int. The same for the second printing structure, b equal 1 dot, you have this print, then type of b, comma, so after this one it will be written the type of b, and you see that you have class float. So it's something which is different. B is not the same object as A. A is an object of an instance of the int class. B is an instance of the float class, has different methods in general, different attributes. So there are two different things. Now, this is another instruction. This is a text. This is really an equation. A double equal B. This is not an assignment. When you write double equal, you are comparing, you are making a comparison between two variables, two objects in general. And this equal will check if the two values are the same. If I run here, I get true. So the two values, 1 and 1 dot, even if the variable are different classes, belong to different classes, the two values are the same. So 1 is equal to 1 dot is true at the level of values. But if I ask A is B, if I call this A is the same object as B, you see this is false. Because even if the value is the same, if the values are the same, the objects are two different objects. One is a float, another one is an integer. So be aware of this difference between the value of the object and the objects themselves. Then you have this type conversion. If I have, for instance, a value which is a variable which is an integer, this A. Oh, by the way, all the value which I write here in a cell are stored in the memory of the notebook and the memory of the environment, and so can be transmitted in different cells. So in this case, I write C equal float A, and the Jupyter notebook, the environment, already stored the value of A. So the Jupyter notebook now knows that A is equal 1, so it is an object of type integer whose equal with value is 1. And I apply this function float to A. So I take this value, which is an integer, and I transform it to a float number. So I click run, and you see that I get print C. So I want the value of C, so I print C. It is no longer 1 without dot, it's 1.0, which signals that your object has been converted to a floating point number. It is being assigned to this variable C, which is a float, is an object of the float class. You can also do the reverse. So you start, for instance, with an integer, with a floating number. You can convert it into an integer, but you have to take care of this problem that may arise here. I write A equal 1.2. So I reassign the value of the variable A. Before it was an integer. Now I reassign it to a different value, which is 1.2. So it is a floating point number. And then I take an integer. So I convert this A into an integer. But wait a moment, A is not an integer, it's 1.2. So what about this 0.2? Well, this B will be simply lost. B is a new variable, which is an integer, whose value will be simply 1. So you have truncation of your floating point number into an integer, and you will lost the decimal part. This is not rounded. This is not, if I write here, for instance, 1.A, instead of 1.2, and I reround the cell, you see that what you obtain by truncating this 1.8 to the integer is 1. This is not 2, which is the next integer. Which is just 1. So int truncate your floating point number, and I transform into an integer and assign the variable B. So B, the type of B is the integer, the type of A is the float. If you want to round, so your number, so you want to transform A into an integer, but you want to take care of the generally as you want of the decimal digit you have. You can write, for instance, an instruction like that with round. Round is a function that takes a floating point number and transform in another floating point numbers with 2 decimals. In this case, you have this 2 that I wrote here is the number of decimals I want. Then I print the results in this esoteric form. Now I will not tell you. Well, I will tell, but not immediately. You see that I have the value A, which is 1.22345, and B is being still a floating point number, but only with 2 decimal. And this round is made in this way. For instance, I have 2285, and I make the computation. You say I made the transformation. You see this, the value A, and B is being rounded to 1.23. So not 1. It is not truncated. It is approximated to the floating point, which is closest to the one we are considering here. The print function here is a little bit esoteric. You see that I have a strange structure. I start with an F. Then I have apices, open and closed. You have these braces here, and after the last apices, I have this format A and B. Well, essentially what is doing, just take this string that should be formatted with this, I'm telling to the interpreter that I expect the string will be formatted because I put an F behind, behind here at the beginning, and formatted according to, by putting in the braces here, A and B, the value that are written here. So, for instance, if I write here A, just to show what happened, you see that what is written here. I written twice the same value because the print instruction see that I have to write A equal to, then expect a value in this to be substituted in these braces, and the value should be taken from the argument of this format method, and the value will take the value A, so this A is put it here and printed here. Then in the second instance, I have B equal to, and then all the braces, and it spreads another A, not B as before. So it will take the value A, which is written here, and it will be put it here, and it's written. So it's right. This is not correct. It's right. Twice the value A. In this case, otherwise to write the value B. So that's the meaning of this strange print instruction. It can this is useful. That's just one way to write string for printing. There are many different ways. We will see some other example. You can have the same output in this way. So you see here in the cell, I write the variable A, then I round it to 2 decimal. I signed the new number in the B variable, then I print both A and B. Here I do something different for printing purpose only. So I'm not interested to storing a variable which is only 1.23, for instance, or 122. But I just want to print B, just want to print A with only 2 decimals. So I can write this other instruction, which is very similar to this print instruction here. This one is very similar, the same philosophy, but I have 2 braces. In both braces, I will put the value of A, but the way I will print it is use some format. So I use a format here, .2f, for printing the value of the variable A. .2f means don't care about a number of digits you have to specify for the integer part of your variable. Print just 2 decimal and use the floating point number notation. So I write here an F. And then what is happening here is I write A equal to this number here within all the decimal digit, and then around it A is 1.22 because this is the format I requested to print the variable A. If I write here E instead of F, you have the scientific notation. So 2 decimal digit, and E, this means for 10 to the power 0 in this case, just 1. If I have A equal to 121, for instance, and I run this one, you see that I have using the scientific notation with exponential 1.01 times 10 to the power 2. That is the meaning of this number here. That is realized by specifying a format in the braces that contain the variable I want to print. This is another way to print the same thing. You see, I have my new variable here, 101 and so on, and I write the same printing instruction in different way. So I put here all in the parentheses. So I have the string, and the string is interpreted by putting instead of this %.5f and %.2f, I will put what is written here after all the percentage symbols here on the right of the instruction. So the first %.5f will be exploited by this variable a, and the second one will be exploited by the second variable I. And this argument, these two variables must be written inside two parentheses and preceded by the percent character. By the way, these two number of these generally a given set of numbers enclosed in parentheses is called a tuple. Tuple, right here, a tuple. Otherwise, if the numbers are enclosed inside square brackets, they are called the list. But there is a difference between the tuple and the list. And I will show you later what the difference really is. You can have other type of objects too. And in the case of print, with this syntax, you are required to use a tuple. Okay. Now, implicit conversion. All the information I gave above concerning the printing, you will learn to use it by making exercise. We will encounter many other examples, but you will not learn it just by looking at what I wrote. You have to try yourself different possibilities. Now, implicit conversion. Suppose you have two numbers, a equal 1 and b equal 1 dot. So one is an integer and the other one is a floating point number, and you sum them. So, sorry, here. So you sum a and b. Then you print the value of c and the type of c. And you see that c is a float. So before the summation is done, the Python interpreter converts the a number to a float. Then this will become one dot. It is summed together to b, so you get 2 dots, and the value is assigned to the variable c, which is a float number. So you have implicit conversion every time you make some operation. In this case, an integer is transformed to a float and the operation is done. Then, as I told you before, these numbers enclosed in parentheses are tuples, whereas numbers in square bracket are lists. This is an example of list. Okay, so I write the list which contains the number 1, 2, 3, 4 are all integer numbers, and they are assigned to a variable which is d. I call this variable d. And the type of d, even if its d is contain all integer number, the type of d is not integer. The type of d is a list. So list, the d is an instance of another class, which is the class list. And being in a class list implies that it has some attribute and some methods. I will explain much later what an attribute is and the method is, but which are different from the attribute and methods that other classes may have. For instance, the attribute and method of a of the integer are different from the attribute and methods from the class list. The elements, I can retrieve the elements of the list by using square brackets. So here is one point. D is a list. Every element in the list have a position. Every element has a position. And the position is a number inside the list. The position is expressed by integer numbers. And Python, as many other languages that use logic by this one, start from the number of the elements in the list start from 0. So The 1 here is the element at position 0. The 2 here is the element at position 1. The 3 is at position 2, and 4 is at position 3. So if I want to retrieve the element which contains the number 3, so I want to retrieve the element 3, I have to write d square bracket 2. So the square bracket is a way to retrieve the element which is in position, in this case 2. And in position 2, we have 0, 1, 2, we have the number 3. So the d2 is the number 3. And I print here this number and the type of this number. Type of d, not type of d, but type of d square bracket 2. So the element 3. So I run the cell, I see that the number is 3, and it's of type integer. This is an integer type of the class that belongs to the class int. So the list of integer is a list, so a class list. The element in this case are just integer number. Well, differently from NumPy that we'll see later, in Python, the list of element of a list, like in this case, are not required to be of the same type. You see, all this is in this list D, all the elements are integer numbers, but I can write a list containing different elements, different types. For instance, here as an integer, here I have a string, and I have here a floating point number. And again, if I run my cell, I see that my sorry, here it was an error. It was an error. So just copy this from home. I have the e variable is still a list pertaining to belong to the class list, and the element of different type. So the 1 is the element of class int. This one between these apices is not a number. It appears as a number, but it is not a number because it is enclosed in apices. So it is a string. As such, belong to the class str, which is the string class. And the last number, 1 dot, is a float number. Okay, what we can do with the list? Well, one simple operation is we can reassign the element on the list in this way. For instance, I take my list E, and I want the element with index 1, so start from 0, 0, 1, so I want the element string 1, be substituted by the number 2, by the integer number 2. And so I write E1 equal 2, and I print it, I print my list, I got 1, 2, 1 dot. So you can reassign lists in this way. This position that I write here, this E1, specify the position, must be an integer number. If it's not an integer number, you get an error like this one. You see, right? Write ed equal 1 dot, and then I ask the value at position 1 dot, but the 1 dot is not an integer, of the array A. And so I would like to got this 1 number here, but I don't. I got an error because I write here ed equal 1 dot, and the Python interpreter complains and say, right, list indices must be integers or slices. We will see later what is slice, not floating point number. So 1 dot is wrong. See if I write here, I correct here by writing ed1, I got the number 1. So be aware that you want to assess elements of a list by using the position they are in the list. You have to use integer numbers and not something that seems to be an integer number because I have just 1, but it's not an integer number, it is considered a float numbers. Pay attention also to the nomenclature I'm using here. So the position inside the list is called the index. So later I will not talk about in position of a number, position of an element in the list. I will talk about an index of an element on the list. So take care of the nomenclature I'm using. And the list is called iterable. It's not only the lists are called iterable. Everything that contain elements indexed in some way are called iterable. It is important not for this lecture to understand the term iterable. It is necessary to understand the nomenclature because the error message that Python or the interpreter print out use this nomenclature. So, for instance, you could get strange error like I click here on the plus button and I create a new cell, and I have my list with this element 2, 3, for instance. Okay. Then I say I want the position of the last position of the iterable A, which is 3, but instead of writing A square bracket 2, I write A parenthesis 2, and I run. Okay, it is telling me that in this case I got list object is not callable. A list object is not callable. This is the list, and it is not callable because when the compiler or the interpreter see the parentheses, in this case, the some parentheses, it understands it should be a function. And a function is callable. What you do with a function, you write a function and you call the function to do it works. But so if I write here, hey, parenthesis 2, it seems that I consider A to be a function, and a function is an object which is callable, but A is not a function, is an iterable, is a list, and so this list object is not callable. That's the error message I got. So the error message from Python can be quite mysterious some way. And so probably the first time you use it, you will not understand what they say, what is suggesting it will do to correct the problem. But so you have to understand, you have to know the nomenclature the interpreter used to communicate with you there. Okay, I can delete this cell by clicking on the shift here. Okay. And then there are two. Now it's midday, so I will stop here and we'll start again at 2 o'clock. In the meantime, at lunch, try to rethink to all these things that we did before, and to make questions immediately when we will start again. It's the afternoon. I think that the first approach to Python for people who have no experience in programming is quite terrible. It's a nightmare, maybe a nightmare, but don't give up because things will clearer, and not say this afternoon, not maybe even tomorrow morning, but the next lectures start for the third lecture. Maybe you will be a little bit more familiar with these ideas, concept tools that we have, and you can understand better. So questions now that you may have. Do you think I'm going too fast, too slow? No questions? You are both, all of you are terrified by this first approach?
Mauro?
Yeah?
I do. May I ask, it's a sort of, maybe you're going to address this later, but in the lists, and you made the point that Python uses index numbers starting from 0 being the first list. Is it possible, maybe you show us later, to either redefine that default to start from number 1, or just maybe even to define the range of index variables pointing to a list?
No, it is not possible to redefine the default because it is really at the kernel of Python. So
Okay.
changing it is not only a matter of be more useful for the user, but will crash everything because all the logic of Python is based on this. You can, of course, write your function using some trick. For instance, if you start to think from 1 and not from 0, you write your index starting from 1, and then when you have to assess the value inside the list, just write your position -1, and so you will scale all the index to 0 initial point.
So I see another advantage to Fortran where you can define in arrays the index range explicitly.
Yeah. No, you can't do that in Python.
Okay, thanks a lot.
But when you start to work with it, it's no longer an issue. So you get acquainted customer to that. So there's no problem. It's not a problem. It's a question of habits. Okay, other questions? Okay, no questions, so we will see you at 2 o'clock. Goodbye.
Bye, thanks, Mauro.
Bye, thank you.
Bye.
Thank you.
Bye, thanks.